Aw. Okay. Okay. So we're asked to differentiate y equals 2x minus 3 to the third and 4 minus x to the fifth to the fourth power. So I reached into my... Did you try this one?
I just think maybe there was an issue with simplification. I don't know.
Okay.
Just wasn't.
Good answer. Let's do it. So first is function 1 and this is function 2. I have to use the product rule and the chain rule. Okay, ready? Everyone? Okay, so can anyone tell us the product rule quickly? Anyone?
F or prime F prime 1 times G plus or minus or plus 1 times prime 2.
Okay, so of course you can twist them if you want to. If the book says differently and you prefer that, that's fine. But careful with the quotient, because if you reverse them in the quotient, then that's wrong and that will bring 0 points. So if you keep 1 prime times 2 minus 1 times 2 prime over 2 squared, it's okay. You can twist this inside 2 and 1 prime. You can write 2 prime and 1. But if you reverse these two, like I have seen in other papers, not in yours yet, because I haven't graded anything for today, then this will be 0. So if you change the order in the product, it's okay. But if you change this order and put the minus in front of the opposite product, then it's 0 points. Be very careful. Okay, so I differentiate the first function. So can anyone tell us how to differentiate it? Lake, how do I differentiate 2x minus 3 cubed? Please.
It's just 2. Oh, cubed? It would be 3 times 2 squared. What? Oh, 2x minus 3 squared.
Multiply by the inner function prom.
4 times...
The inner function prime. The inner function prime.
2.
Good. Multiply now by the second function, which is 4 minus x to the fifth to the fourth power. Now I put plus. I don't want to continue here because I already wrote too much, so I'm going to continue underneath. I copy the first function, and I multiply by the second one prime. Who would like to tell me the second one prime, please?
Be 4 times 5x to the, or negative 5, wait. Yeah, wouldn't it be negative 5x to the fourth?
Plus 4.
It would be 4 minus x to the fifth.
To which power?
Third.
Multiply by the inner function prime, which is?
5x to the fourth.
One more time.
Negative 5x to the fourth.
Excellent. Good, we got it. Good, so now I have to clean it up as much as I can before I decide what needs to be done next. So these two have to be multiplied, and I put 6 in front. So 2x minus 3 squared and 4 minus x to the fifth to the fourth. Now I have a 4 and a negative 5, so that's negative 20x to the fourth. And now I copy these two. 2x minus 3 cubed and 4 minus x to the fifth to the third. At this point, I look and see what I can pull out. Can anyone help with the common factor?
2x minus 3 and 4 minus x to the 5th.
So first of all is 2, because 6 and 20 have 2 in common.
Okay.
It's 2x minus 3, awesome. Which power?
The smaller ones are 2.
Always the smallest one. And then also we have 4 minus x to the 5th, to which power?
3.
Yes, awesome. Now I want to open a bracket. It would be closed here. So let's see what is left from this term. There are 2 terms only. This is one and this is the other. So can anyone help with what is left from the first term? Noor, will you tell us what is left from the first term?
She had to use the restroom.
I couldn't hear you.
They had to go to the bathroom.
Yeah, she said in the chat she has to go to the bathroom.
Okay, very good. Thank you very much. So, Haber, would you like to try? Amanda, Brianna, anyone?
Sure. Would it be 10x, or sorry, 20x fourth?
Okay.
Oh,
What is left from the first term, please?
First term.
4x minus 5. 3 times 4x minus 5.
Excellent. This from 6 I took out a 2, so the 3, there is a 3 left. Awesome. These are completely out. From 4 I took out 3, so there is 1 left. Great job. Good. So now we have here, we have minus. Okay, Noor, are you back? Noor, are you back? Will you help with this?
Back in.
Okay. Amanda, would you give it a shot?
It would be 10x to the 4th.
So you have 10, very good. X to the 4th, awesome.
Times 2x minus 3.
That's it, awesome. And this is completely out. Great job. We have to perform the operations here. We have to distribute. So this is the 12 minus 3x to the 5th. And when I multiply these two, I get negative 20x to the 5th. When I multiply these two, I get positive 30x to the 4th. Is everyone comfortable with this?
I have a question.
Please.
Not about the end of it, in the beginning. So, I understand the product rule. I understand like how you take the 1 prime times 2 and then 1 times
Yes,
2 prime.
this one, yes.
Yeah, I get that, but I'm not understanding why when you're taking the prime of, for example, 2x minus 3 to the 3rd, why the prime of it is what you're putting. I would have thought that we would have used the like rule about the inner and the outer to solve it or something.
Exactly, exactly. This is the inner and this is the outer. Exactly. So 3 comes in front
in the product
times the inner squared, because I have to subtract 1 from the power, times the inner function prime. Exactly. It's the chain rule, yes.
So you did the chain rule inside of the product rule?
When I differentiate something like this, I have to use the chain rule. I have no other way. So when I differentiate this part, I have to use the chain rule. I have no other way. How do I differentiate a function raised to a power prime? I have n f to n minus 1 times f prime. That's the rule at all times.
Yeah,
regardless of where it is. Anywhere I have to differentiate this, I have to use the chain rule.
Got it. Thanks.
Excellent. Other questions before we continue? Okay, so here I'm going to write negative 23x to the 5th plus 30x to the 4th and plus 12. And I will only factor out negative 1. So from here, I'll circle the answer, the continue, where it continues. I copy everything, but I put a minus in front with a 2, and 2x minus 3 squared, and 4 minus x to the 5th to the 3rd, and now 23x to the 5th minus 30x to the 4th, and minus 12, because there is nothing else I can do here. Very good. My suggestion always, do not start any homework before you redo the problems we do in class. That is extremely important, because you get stuck from the first problem. They're not easy situations to look at. Perfect question. Anything else? Other questions? Anything you would need me to do? Anything?
If no one else has any other ones, then I put another one in.
Of course, yes. Any question? Yes. You're helping me, you're helping everyone else. Yes. Oh, you already sent it to me. I'm sorry, I forgot about the other one. Okay, so here we have a function y, which is 1 over u squared plus u, and we are told that u equals 15 plus 4t, and we are asked to find dy over dt. Perfect question. Thank you. Thank you so much. What I would do, I would plug in u in here. That's one option. It's not the only option, but this is what I would recommend. So I have y equals 1 divided by, I have 15 plus 4t, everything squared, plus 15 plus 4t. It's not the only way. Okay, then I will continue trying to simplify this as much as I can. So I have 1 over, I'm not going to continue there because you know me, I always run out of room. So we continue, and this is, how many terms do we get when we square 15 plus 4t?
Do we get 3 terms?
Absolutely, always. When we square a binomial, we always get 3 terms. We square the first term, and we get 225 plus 2 times 15, which is 30. 30 times 4 is 120t. Plus, sorry, the second term squared, which is 16t squared, and then I copy the rest. Finally, I arrange everything in descending order, starting with the highest degree, or the degree of the polynomial. 120 plus 4, 124t, and then 125 plus 15 is 240. 225 plus 15 is 240. I still have one more preparation for this. I don't want to use the quotient rule when the numerator is a number, no variable. I'm not going to use it. I'm not going to use the quotient rule. But then what am I going to do is this. 16t squared plus 124t plus 240, everything raised to which power?
-1.
Excellent. -1. This is what I want to differentiate. So I have, and then I'll show you another way. So dy over dx, or if you want y prime, same thing. Can anyone help us? Noah, are you back?
Yes, I'm back.
Very good. So help us differentiate a function raised to a power. Alex, will you give us a hand here? Alex?
I'm sorry, what was the question again?
Yes, we want to differentiate this. How do we start?
Okay, so -1.
Excellent. -1 in parentheses 16t squared plus 124t plus 240 to which power?
So -2.
Very good. Times the inner function prime. I don't have enough room. I'm going to continue here.
32t plus 124.
That's it. Great job. Thank you very much. So then we have negative. The top, let's see what I can factor out. I like to factor out. Can I factor out from 124 more than 4? No, I cannot take more than 4. I'm going to take 4 out. So I have 4. All this goes back to where it came from, into the denominator. And then I have 8t plus 31. 4 times 8, 32. 4 times 31. And this is final.
I have a question.
Yes.
Okay, so I'm still a little bit confused, and I got the inner function, the 32t plus 120. So
When I differentiate 16t squared, I move 2 in front. I multiply by 16 to get 32. 124t prime is 124.
okay.
Okay, so also we have a different situation here. So we know that we are asked to find dy over dx. We can do it in 2 steps. As dy over dt, du, I'm sorry. It's u, it's denoted by u. Sorry, I don't want to confuse you. Let me erase this. It's not t, it's u. Okay. Multiplied by du over dt. Multiplied by du over dt. I'll write it one more time. dy over, it was dt, yeah. Okay, I'm going to write this. You don't have to write it a second time. I just want to make sure it's clear. So the question was dy over dt. And we know that y is a function of u, and u is a function of t. So then we will write, I'm going to write this one more time. dy with respect to u times du with respect to t. This product should give us the exact same answer we obtained a minute ago. So let's do that as a different way. I'm going to copy those functions here one more time. So we have them. It's a very good question. Thank you, Rita. So u squared plus u, and because I don't want to go back to that page, 15 plus 4t. Okay, I have them right here in front of me now. So first, let's start with the y over du. So dy over du. Of course, I'm going to change it into u squared plus u, everything to -1. And I am going to differentiate this. So can anyone help? Anyone who has not said anything tonight? Like Gabby, maybe? Shvam, would you like to try?
Are you just trying to differentiate it?
Yes. Yeah, of course. I keep you. I'm
would it
sorry.
be,
Yes. You're right.
negative,
Yes.
and then 2u, right?
So we bring down -1. What happens next?
I don't know. I thought that you would find the prime for u2, so it'd be u.
Shvam, will you help? Shvam, are you with us?
Yeah, but I'm not really sure.
Still u squared plus u in the middle, right?
U squared plus u to which power?
-2.
-2 multiplied by
2u
2u
plus 1.
plus 1. Great job. Okay, so then minus in front, 2u plus 1 divided by u squared plus u, everything squared. Okay, so we have now this piece. Now we want to determine this piece. du over dt, very simple. Du over dt is just 4. So I'm going to write du over dt, that is just 4. So now the final answer, dy over du equals 4 times this with minus in front, so negative 4. But now I have to replace here u by what was given to us. The 15.
Wouldn't the final answer be dy over dt? Because we already found dy over du.
So one more time. We are trying to find dy over dt, not dy over du.
Yeah, you just
So-
wrote down dy over du equals.
Yes, I'm just trying to put these two together now. I have this now and I have this, and I'm trying to write. Oh, you're
Okay,
right.
yeah.
You're right. I'm wrong again. Yes. Correct. Thank you. My apologies. My mistake. Yes, thank you. Yes, I want dy over dt, correct. Which this is for negative, I mean, it's a minus and I have a 4 for this. And now I copy this, but I cannot copy it without replacing u by 15 plus 4t. So 2 times 15 plus 4t and plus 1 and over 15 plus 4t, everything squared plus 15 plus 4t, everything squared. And this has to be identical with this. Identical. So the denominator is very clear, it's the same thing we just did a few minutes ago. The denominator has to be the same with this one. So now we want to see that the numerator is the same thing with negative 32t and minus 124. So let's give it a shot and check. So I'm only checking the numerator. The denominator is clearly the same thing we just did. We squared this, we added this, and it's squared. So I don't need to expand that. We already know it's correct. But we need to check that the numerator is correct to show that both methods are giving us the same answer. So there is a negative 4 outside. Then I have a 30, and then plus 8t, and plus 1. And there was plus 1, correct? I just want to make sure that all the answers are correct. So 8t plus 31. Exactly what we just got here. Negative 4, 8t plus 31. So this answer, obtained in a different way, is the same with this answer, obtained by replacing the function from the get-go. If you want to replace the function from the get-go, you're going to follow those steps. If you say, I don't want to replace the function from the get-go, because I will start with this. I will write this definition first. dy over dt is dy over du times du over dt. I will determine these two separately, and then I will construct this by the product, putting the product together, which we just did. So this was the 4 with a negative in front, so this was the first one. I just wanted to make sure that the answer is correct, and I verified that it's the same answer. Very good question. Anything else? Anyone?
How did you get the